Hello and welcome to CodeSlicing. In this episode, I'm going to show you how to create circular activity indicators based on discrete fading of the individual segments. I've done a couple of episodes on activity indicators recently where I highlight the use of a gradient mask to create a pretty convincing and flexible effect. But that technique does have a limitation in that there is a transitional and continuous quality to the mask that shows up when you've got larger segments. If you haven't seen the other two episodes, or at least the very first one, I do recommend having a look since I'm going to be skipping over the basics to get to the real meat of it. I've already got an activity indicator we can use as a basis to speed things up a bit, and since the segments are rather large, this is one that wouldn't work very well with the previous approach, as you can see. In this tutorial, we're going to turn away from using masks and move into the brave new world of controlling the opacity of each segment directly using animations. We're going to be getting pretty advanced in this one, but before we do that, let's look at a simpler implementation to give us a view on why we have to take this extra step in the first place. In the process, we'll address one of the issues with the technique we'll be using. We've got our animation state variable already set up, and we're setting it to true when this view appears. So what do we want to happen now? Well, we want to animate the opacity, so the opacity of each segment is 0 if we're animating and 1 if we're not animating, because we want them to appear immediately and then fade away. So we can use a nice conditional modifier here called opacity if animating is 0. Since the default is 1, we'll get the behavior we want. But this doesn't help us, of course, unless we have an animation associated with that change in state. Since we're going to be animating each segment individually, we'll need to make that an implicit animation. Before we set that up, let's add a duration constant up here. Let duration, which is a double, equal 1. And now we can add an implicit animation after the opacity modifier. Animation, and this is going to be a linear animation with a duration of duration, and we're going to repeat that forever with auto reverses set to false. Okay, so at this point, we should see all segments animating together, which will give us an idea of the animation we've got on our hands. So let's play that. And that looks pretty good. In fact, we're almost there for this simple case. We just need to put a delay on the animation of each segment, the multiplier of which we can declare here. Let's delay per segment equal the duration divided by the number of segments as a double. We'll calculate the actual delay inside the for each as a constant because we're going to need it again a bit later on. Let delay equal the delay per segment multiplied by the index as a double. And we're going to add that to the animation after the repeat forever clause since we don't want the delay to be repeating. Okay, let's play that. Wonderful, but the start needs a bit of work since they all start fully visible. Let me just play that again so you can see what I'm talking about. We don't want that, and we can address this problem by modifying the opacity of these segments from transparent to opaque during the first rotation, and we're going to be employing just the delay part of an animation to do that. So we add another conditional opacity modifier. Opacity if not animating is 0. So when the animation starts, it animates from transparent to opaque. But we want that to happen instantly, so we need to use a different animation specifically for this. And for that, we can just duplicate this animation we've got down here, but replace the duration with one that's very short. And a pro tip for you is that even though we really want to use 0 here, we can't do that because if we do, the animation will be ignored, including the delay we're relying on. And since it's already got that delay in place, the only thing left to do is to remove the repeat clause. Now, I don't want to gloss over this, since some of you might not be familiar with the use of multiple implicit animation modifiers like this. The rule here is that whatever state is changing will be animated within the context of the closest subsequent animation modifier. So the first opacity state modifier will be associated with this animation, and the second opacity state modifier will be associated with this animation. And this can be a powerful tool when you want fine control over how the various states of your views animate together. Now, if we play that, we've got a really nice activity indicator that solves the problem we had when using a gradient mask. However, and I mean, of course there's a however, or we couldn't get to the really fun stuff. The fading out of the segments, you see, is inherently tied to the duration of the animation. So we can't make it fade out at a different rate than the rate of rotation. At least not easily. Adding a repeated delay seems like a possibility, but that's a rabbit hole that gets into nightmare territory very quickly. So let's talk about solving this thing by using a custom animatable modifier. I'll add one here and then we can talk about the implementation. We'll call it opacity fading modifier, and it conforms to the animatable modifier protocol, which is an animatable view modifier. And as this conforms to the animatable protocol, to make use of it, we'll need an animatable data property, which in this case is going to be a double. And since the whole point of this thing is to be able to fade out the segments separately, we'll also add a fade factor to control that, which is also a double. I've made it private because we're going to use a custom initializer for this one, so let's define that now. Fade factor, which is a double, we'll default it to 1, and animating is a boolean. We set the fade factor property to fade factor, and the animatable data to 1 if we're animating, and 0 if we're not animating. If you're not familiar with animatable and animatable data, I've done an episode where I go into more detail than I'll have time to today, but the gist of it is this. If you modify the animatable data property, and that modification occurs within the context of an animation, then the SwiftUI framework will iterate that value from the start to the end value in accordance with the characteristics of the animation. And since we're going to be inserting our custom modifier here, in this case, that's a linear animation. So when animating is set to true, the framework will iterate linearly from 0 to 1 over the duration we're using for our animation. Every time the framework updates the value of animatable data, which is hopefully every frame, the body is reevaluated, and we can use this knowledge to control the opacity of the segments. And we're going to calculate that opacity in a computed property called animated opacity, which is a double. And before we implement anything, let's use that in the body here. And the implementation of this computed property is where the magic happens. You see, we know that the animatable data is going to be iterating from 0 to 1 over and over again as a result of this animation. We want to use the fade factor to determine how faded out each segment should be at any given point between 0 and 1. And that is actually very simple. All we do is subtract the animatable data from the fade factor, and then we divide it by the fade factor. It doesn't matter if the opacity goes negative, so we're not going to bother with bounds checking here. And that's it. Well, almost. There is one last problem we need to address, but before we get to that, let's use our shiny new modifier in place of this opacity modifier, like this. Modifier, opacity, fading modifier. And we're going to pass in a fade factor of 0.6, and animating is our animating state variable. And at this point, we're ready to go, so let's play that and see what happens. Well, that almost looks fantastic, but it's not behaving as we'd like, and this is the last problem we need to solve. This might be a little mind-bending to think about, but here goes. See how we're updating the opacity here? Well, opacity is itself an animatable modifier. Otherwise, the opacity wouldn't animate at all, right? We've been depending on that up until this point, but now it's causing us problems. What's happening is that whenever we set the opacity as a result of our computed property calculation, that is happening within the context of the implicit animation we've set up here. So the framework is animating those changes. But since we're essentially telling the modifier exactly what the opacity should be on any given frame, we don't want this value to be animated, we just want to set it. Yes, we're using an animation to drive our calculation, but from that point on, we are in control of the opacity, right? To deal with this, we can use the bit of knowledge we learned earlier about implicit animations and how subsequent animation modifiers control the previous modifier animation contexts. So we can add one after the opacity modifier, set it to nil, thereby turning off animations for this specific opacity modifier. Now, if I play that again, you can see that we've got a wonderful looking activity indicator that is as flexible as it is awesome. I can even set the fade factor to a value greater than 1 here, so it doesn't even finish fading out before the next rotation. Actually, as you can see, a nice tip is to set it to greater than 1 when working on your segments so you can see them. And there we are. I hope you managed to follow all that. do have a play around with the source code, which will be in the description if you really want to solidify your understanding of what we looked at today. But if you think the awesomeness stops here, then you're wrong, because in the next episode, we're going to be taking all the work we did today and extracting it out into its own modifier that can be applied to anything, turning it into an activity indicator in one simple line. We'll also take a look at how the mask from the first episode can use this implementation to give the flexibility required to use bespoke designs with no rotational symmetry, so join me for that. It's going to be brilliant. If you enjoyed this episode, don't forget to like the video. It helps YouTube get more eyeballs on this stuff, as well as making me very happy indeed. I've got a lot more content coming, so if you don't want to miss it and you're not already subscribed, then consider hitting that button and you'll be very happy that you did. Probably. As always, if you have any questions, comments or suggestions, please leave them below. But in the meantime, thanks for joining me. See you next time.